Okay, so now we're going to continue on with lesson 5.5, part 2. And if you remember in the last lesson, we talked about long division. Well, there is such a thing called synthetic division. Now, it doesn't work for every single problem, but if you could use synthetic, obviously it's going to be shorter than long division. The problem of the day I'm actually going to work out with you because it's very similar. Well, it actually sets up the lesson for us. So if you look at the problem of the day, it says, what is synthetic substitution? If you remember synthetic substitution, we'd have our little box, and whatever x equaled would go out front, and all the coefficients to the function would go in here. So you have x3, 2, 1, none. So we're okay, we don't need any placeholders. So 1, 8, -7, and 35. What we did before was we would bring down the first number. Every time the number's down here, and multiply by the -6. 1 times -6 is -6. When it's inside the box, we add or subtract. 8 minus 6 is 2. -6 times 2 is -12. -7 minus 12 is -19. -19 times -6 is -144. Or -114, I should say. And -114 plus 35 is -79. And before it's synthetic substitution, this would be our answer, right? So -79 would be if I plugged in -6 for every single x. That was synthetic substitution, not having to worry about exponent rows, order of operations to get our answer. Well, if you remember I told you a while back, synthetic division is very, very, very similar to synthetic substitution. So I posed the question, how do you think you would solve synthetic division? All right, how does it look different? So here's your function. These two will match up. I'm telling you what x equals. Here it's x minus 2. So you first take x minus 2 and you set it equal to 0. Right? So 0. Add 2 to both sides, x equals 2. This is the only extra step. Well, there's an extra step at the beginning and at the end. Now we have x equals 2. Do you see how it looks like this? X equals -6. So 2 goes in front. Draw your box. All the coefficients go here. 4, -13, -5. And now you're going to use the same method as synthetic substitution. So first number comes down as a 4. 2 times 4 is 8. -13 plus 8 is -5. 2 times -5 is -10. Get -15. Now, how this is different with your final answer as well. So the beginning is different, then different. Let me go back to this problem for a second. We would see j at -6 equals -79, right? That would be our final answer before. Whatever the final number was is what your evaluated number would be when x is -6. How does it look different from here? Okay, so we start with an x squared. So this is going to be x to the first power. This is going to be the constant, and this is going to be the remainder. So what I mean by that is how I would write my final answer is 4x, because x squared divided by x is x to the first power, so you always go one exponent less. Then what comes after x to the first? The constant, -5. And then here's your remainder, -15 over x minus 2. Now, you could do long division with this as well. I'm sure you would rather, if you can, do synthetic division. All right, but why you also had to learn long division is because long division doesn't work for everything. Or excuse me, long division works for everything. Synthetic division doesn't work for everything. So that's how the answers look different. This time around, instead of just telling me what it's evaluated at with the number, this is our actual answer, adding all the variables. Pretty much, I just showed you synthetic division in the problem of the day. Let's start to put this all together. So what technically is synthetic division? You guys carry this down in your notes. It's used to divide any polynomial by a divisor. I know it's hard to sort of see that. This is in. Used to divide any polynomial by a divisor in the form x minus k. The remainder theorem. If a polynomial f of x is divided by x minus k, then the remainder r equals f of k. So make sure you copy this in your notes. It has to be in the form x minus k. So let me go back for a second. See how this was x minus 2? This is x minus k. All right, if there's other exponents like x squared, and if you look back here, remainder r equals f of k. When you substitute in the number, this is the remainder, the last one, what the function is at. All right, so now we're going to talk about what's the divisor, dividend, quotient, and remainder represented by synthetic division. Now, the divisor, we start with, is this number up front. But if you remember, I'm going to actually type it here. Let's change the color here. The divisor, like if, for instance, this at the 2, that would originally be what? X equals 2. So we have to write it backwards. So bring the 2 back over to the left. It's x minus 2. So that's actually my divisor there. So it comes from here. And like I said, you have to add the variable back to it. If you notice, no variables or exponents are here, so we have to sort of add them back in. The next term is dividend. And with your dividend comes from what you wrote the coefficients first. Now be careful here to figure out, we need the variables again, right? We go constant x to the first, x squared, x cubed. So the last number is always the constant. You might be saying, well, what if it's not? You would have a 0 placeholder. So this is how we write the dividend here. So what I say, constant, first, second, third power. So x cubed plus 5x squared minus 7x plus 2. Let's see if I can squeeze that over there. Yeah, that's good. That all comes from here. All right. Quotient. Quotient is with your final answer. These all here represent the quotient. Because remember, the last one will be a remainder. We want quotient remainder. So if I started off with x cubed, and I'm dividing by an x, 3 minus 1 is 2. So we're going down to x squared. So it'd be x squared plus 7x plus 7. Where all that came from is right here. Last but not least, the remainder. Remainder is the last number out by itself. We're going to want to write it, it's a 16, right? But we could also write it as a fraction, right? So if you remember how we did it even with long division, we would write it 16 over the divisor, x minus 2. We can get rid of the underlining there. So you could write it as a remainder number, but it's also a fraction, remainder over the divisor. And I'll just add that there. R for remainder. And that's how you label them all. Now, let's actually try a problem last example here. I'm actually dividing using synthetic division, and I have all the little rules set up for you to, help you out. Step 1, set divisor equal to 0 and solve. So I'll do that over here. Take x plus 3 equal to 0. Subtract 3 from both sides, x equals negative 3. So that's step 1. So our negative 3, we set equal to 0, goes out front. Draw your synthetic box. Step 2, set up synthetic substitution and solve. So we start with all the coefficients here. Make sure we don't need any 0 placeholders. We have a third power, second, first, and constant, so we're okay. So put all your coefficients here. Bring down the first number. Every time that number's out here, multiply it by the negative 3, negative 6. 9 minus 6 is 3. Negative 3 times 3 is negative 9. We get 5. And negative 15, which is negative 10. So here's step 2, actually doing synthetic substitution. 3, label the remainder. So I always like to circle it. My remainder is here. My coefficients, I'll just put the letter C, go from here to here, all 3 of them. So coefficient, 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 and the remainder. And now, the last part we write as a new polynomial remainder. Probably the hardest part here, just to get used to. If I have an x cubed, my first coefficient here is going to be x squared. It's always 1 less. So I have 2x squared plus 3x plus 5. And they all came from the coefficients here. And plus, you don't always need to write the plus. You could just do negative 10. Sometimes I like to do the negative separate. And that's a fraction, right? So in the denominator, it's going to be what I was dividing by, x plus 3. Let's move that up here, like so. And that's it. That's your final answer. A lot easier than long division, right? All right, so that's it for the notes today. Take a look. Homework, problem of the day. Lucky you, I actually already did it with you. All you have to do are 2 problems. It says complete the following problems on assignment 12, numbers 1 and 8. And then tomorrow we will pick up with completing the rest of assignment 12.